You see these questions on the screen, but do you know the answers? Do you know why the steam that heats this building is useless for sterilization, while another kind is the perfect microbial assassin? Let's find out. Welcome to our deep dive into the science of sterilization, a critical process in pharma and biotech. This video is for anyone involved in ensuring product safety and regulatory compliance. You'll learn how to identify the ideal type of steam for effective sterilization and what pitfalls to avoid. Moist heat is the workhorse of sterilization for one simple reason. The right kind of steam is an incredibly efficient way to deliver lethal energy. But not all steam is created equal. To truly master sterilization, we need to understand steam in two ways: its purity and its physical state. First, purity. The steam in your building's heating pipes is plant steam. It's made from tap water and often contains additives to prevent corrosion. You never want it touching a sterile product. For pharma and biotech, we use clean steam, generated from highly purified water in specialized sanitary equipment. Now for the most important part, the steam's physical state. Think of it as a spectrum of energy and moisture. On one end, you have wet steam. It contains too many liquid water droplets and not enough energy. It will leave your load soaked, a critical failure. On the other end is superheated steam. Think of this as bone-dry hot air. It's been heated so much that there's no moisture left to condense. While very hot, it's a terrible conductor of heat and is highly inefficient for sterilization. And right in the middle, the Goldilocks zone, is dry saturated steam. This is the gold standard. It's at the exact temperature where it's about to condense, holding the maximum possible energy. Why is this steam so effective? It all comes down to latent heat. When this perfectly balanced steam hits a cooler surface, it instantly condenses from a gas to a liquid, releasing a massive amount of energy. This rapid energy transfer is what destroys the essential proteins of microorganisms, killing them with incredible efficiency. This continuous cycle ensures sustained, effective heat transfer, making dry saturated steam the most efficient choice for sterilization. Now that you're an expert on dry saturated steam, let's test your knowledge with a quick quiz. According to ISO 17665, what is the minimum acceptable dryness value for sterilization steam? The correct answer is B, 0.95. Next question. Why is superheated steam inefficient for sterilization? The correct answer is because it acts like hot air and doesn't condense to release latent heat effectively. Last question. The massive energy released when steam condenses is known as? The correct answer is B, latent heat. Now that you understand our perfect weapon, saturated steam, let's meet our target. In the next video, we'll dive into the world of microbiology to understand what makes bacterial spores so tough to kill. Don't miss it.